Hi, and welcome to the Shiko Math Practice Lab, Learning Through Practicing. And we are in this unit, talk about the limits, continuity, and the differentiabilities. This is our practice set number 7. We're going to take a look at how the derivatives and the rate of changes problem related to the, the derivatives. So if you remember, let's refresh in this units, practice units here, we have 7 topics here. So we talk about all different things, right? So find the derivative by using definition, determine the differentiability. So we cover all these 6 topics. And now we do the topic number 7 is the derivative and the rate of the changes here. Okay, so now let's go to take a look at our assignments set, what type of the problems we have. Okay, so for the first 2 problems here is find the slope of the tangent lines, and by using the different definitions. So we know the slope of the tangent lines, right? So both this problem, they try to find the slope of the tangent line. So basically, what is they want to find? We know the slope of the tangent line basically is f prime x at the given point by using the definitions here, right? So we're not going to do this because we did a lot of practice on our practice set number 5 to show you how to use the definitions and how to use equation number 2, try to do the, find the slope of the derivative. So, if you need more practice, you can go to the practice set number 5 and take a look at how do we do it. And also, when we work on this set, we're going to kind of review that also. So we're not going to spend the time to redo the 3 and the 4. Okay, so now in here, let's take a look. This one is a good problem here. So let's say a particle start moving, all right? So if you take a look here, the y-axis, this is how many meters the particle moved, right? So it's kind of like, what is that? That is kind of like your position functions, right? So, like from the 0 to 1 seconds, it's 1 second to 2, 2 to 3, 4, and here, I guess here, this is not clear, but this does have the, okay. All right, so now the first thing here, we want to see when is the particle moving to the right and when is the particle moving to the left and when is it stayed still. Okay, so here, let's take a look at the moving to the right. Okay. So moving to the right, that means I'm start to, right? So let's see here, you start at 0, then you go, dun, 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 right? So you go the 3 meters. So I know I'm moving to the right. That means this meters is increasing. You from the 0 starting point, and then you move into the mark 3 meters here, right? So moving to the right, this is I know it's from the 0, 1. And also from the 4 to 6, the second 4 at the 4 seconds here, you are at the position of meter 1. Then at the 4, you move to the 3s, right? So that means I know also is increasing. So I know by moving to the right at the 4 and the 6. Okay, so now let's take a look at moving to the left here. Okay, so moving to the left, that means, like in here, right? So when you start to what? When you start to decreasing here. So take a look here, right? So that means at the second seconds, you are in the position 3. Now you go backward. So to the position is 1. So it's kind of like this, like at the 2 seconds here, right? At the 2 seconds, this is a meter, right? You stayed here. This is where you are. This is the meter number 3. Then at the 3 seconds here, then you drop back to the meter number ones here. In order to draw back, you have to go backward, right? So that's why you go to the left. So that's why we said S is decreasing. So what is the intervals here? This is 2 and 3 here, okay? And then when the particle standing still, take a look at the standing still, that means I'm not moving anywhere. So like you take a look at this one's here, at the second, 1 second here, I'm at the position 3. Then when the time move to the 2 seconds, I'm still at what, position 3. So that means I'm not moving, right? So that means the what, S is a constant, right? So first non-moving point is 1 and 2. Then also take a look here at the 3 seconds, like 3 seconds, you are at the position 1. And then when you move to the 4 seconds, you still at the position 1. So that means you are standing there, not moving here. So what is my answer here? It's 3 and 4, okay? Now part B is here, it says draw a graph, that is the velocity functions here. Okay, I'm drawing a graph and it's the velocity function. Okay, so let's take a look here. This is really very good problem. It's kind of give you a very good idea and you clear. Okay, so this is 1, 2, 3. All right, so this is -1, -2. And this is my 1, 2, 3, 4, 5, 6. All right, so take a look here. Okay, so now let's take a look. When the time, right? So when the time from the 0, right? So when the time from the 0 to 1 seconds here. Okay, so here this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. So from 0 to 1 seconds here, this is your position function. Since this is a line, so the slope of this line is what? The slope of this line is 3, correct? The slope of this line is 3. That means the velocity is a constant, it's 3. Am I right? Okay, so that's why in here from 0 to 1, your here will be your velocity function, right? So this is what we said is a velocity. The y-axis is velocity function. And then we also know in here from 4 to 6, also this is the, this is the slope of here is rise over run, it's 2, 2, so it's 1, right? So the velocity is what? It's 1 because it's linear. Linear is a constant, so 4 to 6. So here, my velocity is here, 4 to 6 here, okay? And now let's take a look here. For this one's here from 2 to 4, okay, so 2 to 4 is a line, and so the slope of its rise over run. So what is rise over run? Is negative, right? -2, so it's 2 to 3. So 2 to 3 is -2. So this is my 2 to 3. Okay, now let's take a look at the red one. Red one is 1 to 2. 1 to 2, that means I'm standing still. If I'm standing still, what's that mean? What is my velocity? I'm now moving, right? So it's 0, so here. So the same way for 3 to 4, I'm standing still. So this will be what? This will be my velocities here. All right, so this is a very, very good problem here. So that, after you see that, so you know the relation of the position functions and the velocity functions here, okay? Okay, now let's take a look here. And so for this problem, they said if a ball is thrown into the air with a velocity of 40 feet per second, the height is given by y equal to the 40t minus 16t squares, right? So what is the velocity when t is equal to 2? So this one's here, the height really is what do we say here? This is our position function. right? So we talk about the position function. The derivative of the position function is velocity. Velocity, derivative of the velocity is what? The derivative of the velocity is accelerations, right? So now I want to find the velocity at t equal to 2. So basically, I'm looking for velocity is 2. And then we know the velocity. So the velocity function is the derivative of your position functions, right? So if you code this is position functions here. Okay, now we'll be able to use our definition about the velocity. So we can use the limit. So we can use the limit, this definition, x approach to a, and then we can say f of x minus f of a, x minus a, right? So this is our definition, one of the definition for derivative. Okay, so right now we want to find the velocity. Velocity is derivative. So I will say this is x minus 2 here, right? Then I will have a t minus 2, then the st minus s2 here. Okay, so now you can say this is limit t approach to 2, I should say t, and the st is 40t minus 16t squared. So s2 here, you plug, you plug the s2 in, it will give you 40 minus 46. Right? So it will be what is it give you? So this is 16. So S2, this will be 80 minus 464, right? So we'll give you 16. All right, so this is a t minus 2 here. Okay, so for these numbers here, so remember the way we do the limits. So this is a t approach to 2. This is a t minus 2. You can factor, you can factor negative 8 out. If you factor negative 8 out, this will be the 2t squared minus, the minus 5t. Okay, so this is a minus 5t and plus 2. All right, so now you can factor that. This is a limit t approach to 2. This is t minus 2, then this is a negative 8, and then this is a t minus 2 and 2t minus 1. Okay, and then now you can both in fact cancel that out. So that's what you have here. So you will have a limit t approach to 2. This is negative 8 to 2t minus 1 here. So this is negative 24, right? So this is negative 24 feet per second here. All right. So this is a kind of like, it's kind of makes sense, right? So it's, when you throw in that, right? So when they start to falling down, so that means you are going the downhill. You go, you throw the ball up, then you go down. So that's why the velocity is negative 24 here. Okay. All right. So now let's take a look at another ones here. So the other one is the same thing. So if a rocket is throwing upward on the plane of the Mars with velocity is 10 meters per second. After t seconds here, this is the what? This is the locations, right? So what is this again? This is my position functions, right? So this is my position function. So this is STs here. So this is 10t minus 1.86t squared. So they want to find the velocity after 1 second here, okay? So let's see here, after 1 second. So we say the velocity again is velocity is equal to what? Is equal to 1, right? So you can use the, so you can say this is what? So you can kind of so you say this one's here, and you will say this one, you can say the limit, the t approach to 1, then this is t minus 1, then the st minus S1s, right? Just like we did before. So this is the limit t approach to 1, and this is a t minus 1. Then the position function is the 10t minus 1.86t squared. S1 will just be 10 minus 1.86. It's going to give you what is 10 minus, so it will give, so this is will be 10 minus, so when the t equal to 1, so here it will be give you is a point, so the 8.14, right? Okay, and then you'll be able to kind of the factor that out. So this is a t minus 1. So 8.14. So this one's here, you will have a t minus 1. And then you will have a negative here. Okay. So you can, you can take the negative out, and then this one's here, you will be 1.86t squared minus 10t plus 8.14. And you can factor that. So this is a t approach to 1, and this is a t minus 1. Then you will have a t minus 1. And so what you have here, you will have 6.828. Okay, so you will have, this is the 8.14 t minus 1.86. So when t equal to 1, and then this one you can cancel, and then what you will have here, so this one you will get a 6.28, right? So this is a 6.28. Okay, so I think this one's here, I'm sorry here, so should be, this is 1.8. Okay, so this will be the 1.86 t minus 6.28. Okay, so the 1.6 t plus, okay, 6.28. So this is plus here. So it's a 6.28. Okay, and okay, so let me, okay, hold on. So let's make sure we don't mess up the sign here. Okay, so, all right, so let's clear that out. Right, so here, so I take the negative sign out. Okay, so I take the negative sign out, and after you factor, so you can be careful. This 1.86t, and here instead of 6.28, I just need to be careful about my algebra. So this will be minus 8.14. So yes, so here I got 6.28 meters per seconds, right? Okay, so now the next ones here, they want to find, they want to find the velocity of the rock at the 8 seconds here, all right? So at the 8, so that means in the general forms here. So let me kind of clear that out so we don't override to that, okay? All right, so in here, the B, let's try to use a different notations here. That means I'm looking for the VAs here, right? Okay, so the VAs here, this will be limit, okay? So this will be limit, let's say here, H approach to 0. Let's use a different definitions, kind of practice what we learn. And then we have the S of what? A plus H and the minus S of A here, okay? So now after that, we do the algebra, and I'm not going to repeat the algebras here. So the algebra is very similar. You just substitute to the function. As you can see, will be a little bit complicated. Then you'll be able to factor the things out. And so this will be the 10, right? So this will be the 10 minus 3.72, right? A. So this will be the 10 minus 3.72a and minus 1.86h here, okay? And now you take the h, so this is cancel out. So when the h equal to 0, this number approach to 0. So your final answer for here, this one's here will be 10 minus 3.72a. So like I said, from here to here is just the algebra steps. So you plug the numbers into your functions, all right? Okay, now, so the last one, the part C is here. They say, when will the rock hit the surface? So when the rock hit the surface, that means my position function going to be equal to what? Will be equal to zeros, right? That means the 10t minus 1.86t squared going to be equal to 0. And then you factor, so this is t, you can factor t out, minus 1.86t equal to 0. So you can set equal to 0. So it's t equal to 0 or t very close to what? 5.4 seconds. So it's kind of makes sense, right? At the beginning, the rocket at the ground. Then after 5.4 seconds, you hit it and then going to hit it back to the ground again, so, right? Okay, and now they said, okay, what is the velocity when, when the rock hit the surface here, right? So what is the velocity when the rock hit the surface? So that means we are looking for the velocity at what seconds? 5.14 seconds, 5.4 seconds, right? Now we already derived at the part 2. This is the general formulas. So I can say the 5.4, this will be 10 minus 3.72 times the 5.4. So what I'm having here is negative 10 meters per second. Is a kind of, it's kind of makes sense, right? So because when you throw the rock up, when they come down, when they hit the ground, the rock is going downward, right? So the opposite direction, that's what is this negative 10 means here. All right. Okay. So now let's try to do one more, and we'll take a break for this video, and then we're going to talk about the different topics in the other videos. Okay. So now this one's here. Okay. So it's also, they say the displacement, that's basically is your position function is given by this, and where t is measured by the seconds. Right? So I want to find the average velocity. So the average velocity, like we did before. So what is the average velocity? Is the average rate of changes, right? So basically, you just what? You just, so the rate of the, basically rate of the change is here, right? So average rate of the change, right? So here is the formula we use. Remembers that? So we say the S of the t plus h minus S of t over whatever the h in between. Okay, so now let's try to do couples here, like a 4, 8. What's that mean? That means you put the S equal to 8 minus S equal to 4. So you plug the t with 8 and 4. Now how many seconds in between? Is 4 here, correct? Now if you plug the number in there, so if you plug the S to the 8, S to the 4, what you will have? You will have 0 over 4. So it's 0 here. Okay, so the same way, you can do the 6, 8. So what's that mean? So you plug in the s of the 8, right? And minus s of the 6. Now, how many seconds in between? 2. So you plug back in there and you will find your answer is 1. So, for the remaining 3 and the 4, it's just like a very routine. It's like an algebra type of the work. You plug the value into your functions, right? Okay, so now the number part B is here. They want to find the instantaneous velocity, right? So the instantaneous velocity is what? So the instantaneous velocity, that means is the derivative, right? At t equal to 8. Okay, so let's see here. How do I do that? So I'm looking for v to the what? V to the 8. So what I'm doing here, I say, hey, I have a limit, right? T, approach to what? Approach to 8. And here I have t minus 8. Then the top here is s, right? So it's 1/2 t squared minus 6t plus 23. Then minus s to the 8, right? Let's take a look at s to 8. It's just you put the 8, in here. So it's a squared minus 6 times a plus 23. So a squared is 64 and minus 48 and plus 23. So it will be what? It will be 7th here, right? So then you do the same thing. So this is a t approach to 8. Then this is a t minus 8. So 23 minus 7. Okay, so 23 minus 7 will give you 16 here. All right, so it will give you the 16. And so now you will have what? You will have 1/2. So this one, and save some step here. So this will give you 16th, right? Okay, so now I can factor the 1/2 out. So I can factor, right? So this is t squared minus 12t, and this is 16, so it's a what? 32, right? Okay, so now I can factor this one. Hey, this one is pretty good. So it's t to the 8, right? And then this is t minus 8, then the 1/2. So this one will be t, so it's minus 8 minus 4, right? Okay, so super. So that's it. And then in here, you can cancel, right? So now I can get this one is equal to limit t approach to 8. Then this is 1/2 t minus 4. What is the answers here? Is the 2 feet, right? So what is it's 2 feet per seconds, right? So that means that at t equal to 8, the instantaneous velocity is 2. All right, okay, so now, we did a lot of those problems, right? So right now, this will be a good time. Let's take a break, and then we'll come back to our second video. Let's continue working on this. All right, okay, talk to you later.